Right, as you know, Numpy, Pandas, Matplotlib, Seaborn are the main Python libraries. In addition to that, if you are going to be a data scientist, scikit-learn is one of the most widely used Python libraries too that we are going to use. But for this 10-hour Python course, I will just focus on the Numpy, Pandas, Matplotlib, and Seaborn only. Okay. So let me start with the Numpy. Okay. We have talked about the basics of Python so far. Now we can start processing data science libraries. The first library we will discuss is the Numpy library, which is the foundation of most data science libraries in the Python ecosystem. Numpy stands for numerical Python. Basically, Numpy is a linear algebra library that you can apply various linear algebra operations via Numpy. But the story doesn't end here. We will talk about a module that defines a type of data named array, which is commonly used in data science application too. It's a library consisting of multi-dimensional array objects and a collection of routines for processing of array. Before getting started, you should have installed Numpy on your local environment. If you don't yet have Numpy installed, install it now with X, let me type exclamations mark pip install Numpy. If you have already did this operation, you can skip to import Numpy as np. If you do that, you are all set to use the Numpy after running this line. Okay. Once Numpy is installed, we have to import the package into our current environment to actually use it. We do this with an import statement, as you see here. And we are going to use it for every single libraries that we have. When importing a package, you also have the opportunity to set an abbreviation to recall its functions. Many packages have standard shorthand, which we will follow. The shorthand of Numpy is np here. You can import and set the abbreviation of your choice, but it's, when you are going to use Numpy, by convention, its abbreviation is np. Okay. So we import the Numpy. Let's create an array. As we discussed, Numpy is a fundamental package for storing and manipulating mathematical data in Python. Numpy primarily accomplishes this with a new data structure, which is called array. So Numpy dot array basically tell that I'm going to call an array. I'm going to compose an array. There we go. So here we compose an array, we create an array with an entries of 1, 5, 4, and 3. Okay. A single dimensional array works like an ordered set of values with various data points entered in it. As you can see here, arrays use brackets. Okay. And we create an array by calling this function np.array. Okay. So we can extend this operation. By the way, there is a question, I guess. How do we install Numpy from anonymous attendee? So if the import function doesn't work for you, you need to type exclamation mark and pip install Numpy as you see here in the first line. Okay. All right. np Let me play with this first. np.array. From time to time, I will go back and check the Q&A session. If you have any question, please feel free to put there. 54343. D type is float. Normally, as you see that the D type data type is integer. Now I would like to play with it, and I would like to change the D type to float. Let's do that. Here you see you have the dots here, which means that the integer numbers turn into a float. Okay. All right, let's play with the dimension of the array. We can do that. So Npa Range 8 dot reshape to 4. So Npa Range means that I will have number from 1 to 8. 8 is not included, linear numbers, and I would like to reshape it and to have 2 rows and 4 columns. Okay, let's see how it works. As you see that it's a basic matrix with 2 rows and 4 columns. 1, 2, 3, 4. All right. Npa Range, as you see here, is short for array range. Okay. Works similarly to the basic Python range function by generating a sequence of integers starting at 0 by default and incrementing by 1. Okay, this function increments by 1. All right. Multidimensional array. So array is not a one-dimensional, is not only one-dimensional property, so we can generate more than one-dimensional if we want to. Data nested. This is the name that I assign. 1, 2, 3, 4. This is my first dimension. So I would like to add more dimension. I use brackets here. So the first bracket is by default. You need to do that if you want to have the NumPy array. Then if you want to create more dimensions, then you need to open and close the brackets to do that. All right, so I first open and close the bracket, and inside of it I type 2 different arrays here. You see, this is actually a list, as you see that, because I start with the bracket. Normally I start with the parentheses, but inside I use bracket too. All right, this is array, but I can turn it into a, this is list. I can turn it into an array. Let's do that. With this, we use these conversions a lot in data science and in other basic operations. Let me assign a name to this operation, data2. Let's see how it works. All right, so here you see we have 2 rows, 4 columns. Now I would like to calculate the dimension with the built-in Python code and then number of dimension. This means this is, for short, this is the abbreviation of number of dimension, by the way. And hold on a second, \n. If you do that, I will move to the second line. Okay. The other thing that I would like to show is the shape. Number of this function and dim function gives you the number of dimension, and shape function gives you exactly the number of rows and columns. Let's see. So here you have 2 dimensions here. You see, rows and columns. And here you have 2 rows. Shapes give you the number of rows and number of columns, which are 2 and 4 respectively. All right. So let's discuss the basic arrays. So we can generate our own array, something like that, array 0, 0, 0, 0, something like that, or we can do it by using built-in functions like this. Okay. So let me generalize this statement. Print np zeros 10. Next line. Print np ones. I'm going to define the dimension of it. That's why I need one more parenthesis inside the parenthesis and the entries. I can define the entries. Oh, it's one, sorry, no entries because it's once already. And then backslash n. Right. This is nothing but zeros. The entries are nothing but zeros. Here in this case, np1s, the entries are nothing but ones. I produce diagonal matrix, let's say 5 by 5 diagonal matrix, and one more stuff, which is np full 5.56. If I do that, I will have 5 by 5 matrix with entries of 6. Let's run this. There is something wrong here. Oh, still there is something wrong, the comma. All right, so still, which one is that? The third one, I guess. MP33. This is not necessary. All right, I forgot this one too. What now? 5, 5, parentheses, parentheses. Okay, there is something wrong somewhere here. How about this? Okay, how about this? Still, that's weird. Which one is that? I, here, I get an error, MPI. Why is that? oh, sorry about that. I don't need this. Oh, how about that? All right, I fixed the problem. So MP zeros produce nothing but zeros with 10 entries, and MP ones has an entry of 1, only 1. It's 5 by 5 matrix, you see. MPI produce a diagonal matrix. Diagonal matrix has an element on diagonals and zeros in the off diagonals. And MP full, you can design your MP full. This is my choice. I generate 5 by 5 with an entry of 6, nothing but 6, right? So these are the basic arrays. How about basic indexing and slicing? We use slicing a lot in Pandas and Numpy, by the way. So it's great for you to know that. So you know how the Npa range work. It's something like this. It has 10 entries, but it's, doesn't include the last one, 10. I will make a selection. I will show you how. I assign a name data to the Np range 10. I will make a selection. I will select second index all the way up to 5th one. Okay, let's see how it works. So this is the first index. Okay, this is the it starts from 0, 0, first, and second index. You see, second index here. And then third one, and then fourth one. 5 is not included here. So it includes 3 observations, which are 2, 3, and 4. Okay, this is how we do slicing. After typing the name of the data, we open a bracket, design the slicing of your choice, and close it. That's all. So we can define different slicing based on our choice. If you want to select the last observation, you can type -1. You can do that. Or if you want to select the first index, you can do that. Data 0 inside the bracket. Or if you want to choose all of the entries, all of the observations, use colon here. You see, colon. Just use colon inside the bracket. Then you choose every single entries in the array. How about slicing both rows and columns? Let's do that. np.array. I said I open and close a bracket, and inside I open another one because it will be a multi-dimensional. 1, 2, 3, and that's all. The other one is 4, 5, 6. The other one 7, 8, and 9. Okay. So this is my array. This is multi-dimensional array, as you see. Let me assign a name. So this is my variable name, data2. Print data2. I would like to select 0, 2, which means that I'm going to select the first row, and inside this row, I will select the column, the second one, and it starts from 0. Don't forget that. Okay, what's the problem now? Data2, there is something wrong with the number of columns, I guess. I forgot the comma, sorry. There we go. So how come? We select this one by using 0 here, and I put a comma here, which means that I'm going to select my column. Okay, this is my 0 column. This is my first, this is my second. So it turns out to be 3. First, you select the first row. You can consider it like this. Let me type it first. So this is my first row, which corresponds to 0 index here. And then I take this out, select the second column. So which means that 0, first, second, 3. You have a question? Yes, data inside the bracket column creates a copy of the array. That's right. Why does Python not include data 5 when using? This is how it design. There must be a reason why it. So it starts from 0 index. If you previously used Matlab, the index is 1, but Python choose starting from 0. This is the choice of the programmer. So I don't know if there is any deep down meaning. It depends on the software you use. Okay. What else we got? We did the selection in multi-dimensional case this way, but how about this? We can do it with another way, with 2 different brackets. This is the same thing. You see, we can either use comma or use another bracket, and you can make it separate. Okay. Let's talk about the universal functions that we can apply in NumPy. Universal functions, which are absolute value, square root, exponential, logarithm, floor, ceil, sine, is, NaN for missing values, detecting the missing values. These are the universal functions. Okay, let me type the Let me define a variable x, which is equal to 2, y is equal to 3.6, z is equal to -3. If I'm going to apply the absolute value of z, this is how it works. So let me run this first and then this one. It turns out that the absolute value of z is 3. Okay. If I want to take the square of x, which is 2, should generate 4. You see? All right. How about calculating the floor number of y? As you can guess, it's 3. Okay. How about CL of y? It's 4 because it's 3.6. Okay. All right, these are the basic universal functions in a nutshell. Let's move on to the aggregate functions, which are summation, minimum, maximum, arcmean and max to find the index of minimum and maximum value, standard deviation, variance, median, and percentile. Okay. So let me define a variable x with Npa Range 5. Let me run this. Np mean, I'm gonna calculate the mean of x, which is 0, as I know it, because x looks like this. Okay. X looks like this. How about the standard deviation and the variance of x, Np std x, Np variance x? If I do that, 1.4 is the standard deviation of x, 2.0 is the variance of x. Okay, so what is the median value? Median means that median is exactly the number in the middle of the array. So I have an ascending order, as you see here, 0, 1, 2, 3, 4. This is ascending order. So I have 5 entries. In right in the middle of it, I have 2. You see? Then the median is 2. If I manipulate it, Npa Range 6, I would have this one. So in the middle, I will have these 2 numbers, 2 and 3. So the median should be 2.5, the basic average of these 2 points. Okay, because if I have even entries, in the middle of the number in the middle will be the average of these 2 numbers. Okay, if I have odd number of entries, so it's easy to locate the number in the middle, which was 2, as you can remember. Okay, this is how we define median in statistics. Enough about the Numpy. Let's start talking about Pandas. Pandas is probably the most heavily utilized package in Python for data scientists. Built on top of Numpy, it's essential to data manipulation, organization, and modeling. Here we will introduce some of its core functionalities as well as its primary data structure, the data frame. First, we have to import the package, which typically gets the abbreviation PD. And if you didn't install it into your local computer, you need to do this before getting started. !pip install pandas. You need to run this first. If I run this, it will show that I already require the requirement already satisfied by me because I, already did that. Pandas has two data structures, series and data frame. I will talk about data frame for the time being. Data frame is like a NumPy array with a few additional features like column names and row indexing. It's probably the primary way data scientists handle data. You can create data frame in many different ways, either from CSV files by querying databases or explicitly. For your first data frame, let's create a two-dimensional NumPy array. Then to create data frame, use PD data frame function and pass into NumPy array. So to do that, I will take this, where is the two-dimensional data frame that I have somewhere here? This is my data2 is two-dimensional data frame. Let me show it to you. Sorry, it's NumPy array, but it's two-dimensional. And then shows me that's two-dimensional. It's easy to turn it into a data frame. I can do that, data2. So if you do that, oh, I didn't import the pandas SPD. I need to do that first. Okay, if I do that, this is what I have. Looks nice, doesn't it? So it's a tabular form. We have rows. These are the indexes. And I have columns here. Okay, 0 and 1 are indexes. 0, 1, 2, 3 are the column names. I can modify it. I will do that later on. Let me create empty cells here. All right. So let me define my own data structure from dictionary. You know how to work, how dictionary look like? We discussed this before. I will type the states Ohio. I will repeatedly use Ohio here and Nevada inside the codes. Sorry, Nevada. And then what else? Nevada again. Okay. How about I put a comma and click enter to better organize it. Otherwise, it will be a long line. Years are 2000, 2001, 2002, 2001 again, and 2002. Put a comma, click enter, and the population. These are just, these are not very reliable data, by the way. I don't know the exact population of Ohio and Nevada per year. 1.5, 1.7, 3.6, and 2.4 and 2.9. Okay. I have the data in a dictionary format that I run this, and then I will turn it into a data frame. So I would like to emphasize that it's really easy to convert dictionaries, list, array into data frame like this. Okay, so you have the data frame, but you don't know what it looks like. Let me show how you observe your data frame. Hat helps you to do that. Hat by default produce or shows you first five rows with multiple columns, all the columns. Here you see you have 5 rows by default. Even if I have 5 folds, it's by coincidence. If you have more than 5 rows and type hat like this, you will have 5 rows only on the screen. But you can modify it. Like you can type 10 or 20, or you can type PD max, some blah blah, and you can have full entire rows and columns. You can do that too. but it's not very preferable. Okay, you have any question? What is data frame? Data frame is a data structure in Pandas. Data frame allows us to use rows and column at the same time, so you can deal with multidimensional case with data frame. Okay, so it's consider it like an Excel in Microsoft. Okay, Microsoft Office. It's the same thing. We have tabular format here, rows and columns. That's all, and it gives us a very fancy visual. Okay. All right. Let me modify the column names. Frame.columns equal to states year and top. So normally I have this column names, but it's like small letters. I will turn it into a capital letter here, you see. If you do that and type frame.head again, you modify the column names. Okay. All right. What else we got? We can play with the indexes and we can add or delete columns. We can do that, but I will skip this part to not to spend so much time. Okay. I would like to talk about adding some columns because it's really important. You need to modify your data frame along the way. That's why it's very important for you to know that. George, John, and Thomas. These are the names that I'm going to use. Purchases is equal to PD data frame, index names. So index, I define my index as names. I'm going to use these names as index. This is one of the way that we can specify our index. Okay. Great. So I continue to modify purchases data frame. I will add a new column, which is called country. I assign a name. If I type the name of the data frame and open a bracket inside the quotes, type the name of my new variable, then I'm able to create my own column inside the existing data frame. US, Canada, and what else? Denmark. Okay. This is my first column that I created. I'll continue to create another column, add views. So number of times that the advertisement viewed, it is 10, 15, and 20. I'm just making up the numbers. Purchases, items, no purchases, let's say, is equal to 201. Okay, so I create two different columns. I assign arbitrary entries. If I run this and call the purchases data frame here, this is what I have. I create my own data frame. You can add as many as rows and columns as you like. Okay. So far, so good. So as I said, the selection in Numpy and Pandas are quite important because as a data scientist, we make the selection and filtering a lot. So in Pandas, we use log and ilog very frequently in making this selection in data frame or series. Oh, sorry, in data frame. So log is a selector that indexes over rows and columns. It selects over the row index first and then column name. On the other hand, ilog does the same thing but over in the indices. For example, to select the row for George in our purchases data frame, we just pass the string George into purchases.log with bracket notation. Let's do that. Purchases.log George. So here I make the selection based on index George. George is my index, as you see here. Let me show it to you. I define names as index. Okay, George is my index. I make the selection based on index. At the same time, you can make the selection based on rows too. Okay. All right, let's do that. So this is how it works. Which entries I have based on the indexes is this: US, 10, and 2. Countries, advertisement views, and number of purchases. You see, this is the selection that I can make. All right, how about making selection based on both index and rows? Let's do that. Purchases.log George, comma, country. Country is this. Columns, you can make the selection based on columns and rows, and indexes. Here we go. George, country, and the result is US. Okay. Purchases coming from George, and which country is that? It's US, that's all. Only the result is US. How about making selection using ilog? This I as a first letter helps you to remember that we can make a selection based on integers, right? When I say integer, I refer either row number or column number. Purchases dot ilog 1, 2, comma 1, which means that I will select starting from the first row and at second one, so which is basically saying that I'm going to select the first row and the first column. So first column is this. This is the 0, 1. This is first column. First row is this one. So let's see how it works. John 15. You see? John 15. I have the index, I have the values. So this is how selection works. Or you can apply many different stuff here. Maybe if you prefer to select every single rows you have, but only one columns, which is the first column. I mean, actually it is the second one if you start counting it. So this is how it works. I select every single rows, but the second column, let me say. This is not the first column, this is the second column. So 10, 15, 20. You see, 10, 15, 20. All right, great. So conditional selection. Up to now, we learned how to make a selection based on log and ilog. How about applying some condition on that? We can do that, We can do that using Lambda function, as you may remember from our previous course. Lambda allows us to make the run the conditional statement, or you can use if statement too. But better to know that. Purchases. So this is my conditional statement. You can design your own conditional statement of your choice. Greater than 2. How many item purchase we have? Let me check it first. There is no greater than 2. Greater than 1. Okay. I'm sorry. Push the hashtag there. Okay. What else we got? I will do that. And if I put the comma and colon here, which means that I will select the whole line. There is something wrong. The name is different. No purchases. Sorry about that. Okay. So this statement basically tells us that I'm going to select the number of purchases greater than 1, which is this one. Okay. Which is nothing but this one. Okay. If I don't use this one, I have the same thing, because I don't need to specify the columns here in this case, but I would like to show it to you just in case. So, okay, what we understand from here, we can use log and lambda function at the same time to make the conditional selection, which is quite helpful. Otherwise, you need to design the if statement, and it is more time-consuming process, so it's more efficient. Believe me, it's more efficient. Okay. The last thing about pandas is the grouping, but you have a question, I guess. Can we import this spreadsheet or CSV or recorder from a database to data? We will do that. We will do that. Okay, what is df after lambda? It's by convention, you need to define some variable here. You can do anything you like, but you need to define a variable here for the structure, for the sake of structure of lambda. Otherwise, it doesn't work. Okay, you need to define a variable here, even if you don't use it afterwards. Okay, how about grouping? That's the one last thing we will introduce here. That's grouping. You can create groups in your data frame using group by and passing in the column name. Let's try it because it's really important. I would like to spend some time on it. Purchases.group by. Which variable do you want to use for group by? Let's see. Country, advertisement views, number of purchases. Which one? I select using country. Let's do that. Inside the codes, country. Okay. If I do that, this is what I have. This is an object here. Because I need to specify an operation, which is, in this case, I prefer to run me. So I basically group by countries. So by countries, US, Canada, and Denmark. Let me modify this one with Canada so that I will have repeated categories, and I will add one more US here, and I will add a name here, Abdullah. All right, so I will enlarge the entries. Okay, so I modify the data set. As you see here, I have in total 4 countries, but 2 different ones, US and Canada only. So now I will make the group by based on mean. So I will take the mean of these 2 variables, the numerical variables. If I have string variables or object variable here, I cannot take the mean. That's why they will automatically drop. But here I will group by based on US, and if I group it based on US, I will calculate the mean value of advertisement views and number of purchases, which will be, as you see, 3, 2 times 2 plus 4 over 2. So it is 3. How about this one? 35 over 2, 17.5. Let me see how it works. You see? For the US, it is this one. How about Canada? Let me calculate this by hand. So it is 1 plus 0, it's 0.5. The mean is 0.5. How about this? The same, 17.5. You see? This is the mean calculation per country. So it's quite helpful to use group by. Okay? Great. Do you have any question here? Okay, no. Great. Let me continue with importing data to the data frame. This is importing data from online or from your local computer or from a server. So read CSV. If you do that, if you type, let me create empty cells. If you type pd.read underscore CSV, it means that you are extracting data in CSV format. Okay. Let me type the name of the data. This is the name of the data that I have. You can import your own data in your local computer or in the, online. If you find somewhere online, you can do that. df.heads should work. Here we go. I have this data in my repository somewhere here. Where is that? Here, you see, I have this data here. I call this data. That's all. It has CSV format, and I call it and name it as df, and df.head tells me what it looks like. Now I will use the, by the way, let me show how I can manipulate the head. If I type 20, this is what I have. You see? Okay. So this data set tells me the number of profit that the company gets from face cream, face wash, toothpaste, bathing soap, shampoo, moisturizer, and that's all. So this is the total profit. Okay, the summation of these numbers. Great. If you have any question, let's discuss it now. Any book recommendation for learning all these libraries? Yes, Wes McKinney's book, Python for Data Science from O'Reilly is a good one to review these libraries. And Python Crash Course, I forgot the author, but it's a good one too. You can Google it and you can see that. You can see the book, Python Crash Course and Python for Data Analysis from Wes McKinney from O'Reilly. Okay. Farida typed the results. Why is a pandas data frame is so much useful than a two-dimensional array? Is it because you can avoid writing loops, or no? It provides you a tabular format that you don't have in array. If you have large number of rows and columns, it's really hard to observe the array, observe the entries, but you can do that with pandas data frame. And at the same time, pandas has some more built-in functions compared to NumPy. It's easy to manipulate pandas and then check it by simply observing it. It's something that you cannot find in NumPy. A question from Farida. When I perform the std_var median function on my computer, I got this, which are different in your computer. Why does this happen? Because I changed the number. I changed the number. That's why. I manipulated not to have this number. I add a number to calculate the median in even number of entries. In the case of even number of entries, that's why we have different numbers, Farida. Other than that, it's all the same. All right, let me continue with the Matplotlib, one of the basic visualization libraries in Python. By the way, please note that Pandas has its own plots, line plots, scatter plots, the most basic plots. You can use Pandas to call these plots. The way you type the code is slightly different, but you will have the same visual. Okay, anyway, you will have the same graph. Matplotlib is a Python plotting library which produce publication quality figures in a variety of hard copy formats and interactive environments across platforms. Okay. Matplotlib tries to make easy things easy and hard things possible. You can generate plots, line plots, scatter plots, histogram, power spectra, bar charts, scatter plots, box plots, and so on with just a few lines of code. Okay. So again, if you haven't used the Matplotlib before, you need to call it pip install. Okay. plot. This is how you need to call. Okay, after running this code, you need to type import matplotlib.py plot as plt. By convention, we use plt as the abbreviation of matplotlib.py plot. Okay, I will use this data set you see here and then make the visualization. Okay, what's the name of the data? df, by the way. Please note that. df, let me type the library first, plt.plot. If I do that, I will have the line plot. Inside the parentheses, df total profit. This is how we select the column, as you may remember. I will type the name of the data set first. I open a bracket. Inside the code, I type the column name and close the brackets. Okay. If I want to assign a name to X and Y label, this is how I can do that. Mount, and then Y label, the label of Y-axis is profit, or anyway, it's profit. Okay. Let's do that. Here, what we see is that as time goes on, profit goes up. There is a trend. Okay. Sorry about that. So this is a line plot. This gives you how the profit evolves based on the mount. Okay. If you don't want to have this text here, you need to type plt.show. Sorry about that. This one. Okay. Let's continue with another example. plt.plot df, again, total profit. Total profit. Now I'm gonna add some more parameters, color, for instance. I will play with the color of the graph which is by default blue, but I prefer using red in this case. Marker is a parameter that we use to specify the line. So here it's a straight line, but I use circle instead. You will see what it looks like soon. Line style. If I do that, I will define my line style, which I use dashed. Line width, by using this parameter, you can create thick or thin lines. Here I define it as 3 and label. If I do that, I can generate legends. Monthly profit. Okay, sorry, monthly profit. All right. Plt plot, name of the variable that I would like to observe, color of the line, type of the line, style of the line, width of the line, label of the plot. All right. Plt x label, which is months, and Plt y label, which is profit. And if I have this label and if I would like to use it, I need to type Plt legend here. If I do that, I will have the legend on the screen. You can define the location, and I prefer to use best. I leave it Python to decide where to locate the legend. Python automatically finds the best way to put the legend on the graph. All right, let me run this. This is what I get. I have markers here, dashed line with 3 millimeter thickness. Label is monthly profit, as you see here. Let me type a plot title for the entire graph, total profit. All right, looks nice. And Plt show, even better. Total profit is the title of the entire plot. Profit is the label of y-axis. Months is the label of x-axis. Plt legend location of the Plt legend is the upper left corner, which is the best one. I didn't decide it. Python did. That's all. By doing this, I show you how you can play with the parameters in Matplotlib. Okay, this is the line plot, by the way. I said that before. How about scatter plot? Scatter plot is used to compare two different data sets, two different variables, or you can use it instead of the line plot too. So I will make the selection, column selection, which one, depending on which one I want to use, df mount number. So if you pay attention here, I can make the selection using brackets and quotes, or I can do the same thing by using dot here. These are the same thing, but it is safer to use brackets and quotation mark because from time to time, some functions require selection like this, like this one. They force you to do that, okay? And for instance, as far as I remember, it's box plot. They do not admit this format, this selection type. Okay, anyway, so if you want to be on the safe side, use brackets and quotation mark to make the column selection. Toothpaste. So this is my x-axis, month number. This is my y-axis. Okay. And let me define the label. which is put paste sales data. My title is paste sales. Plt X label is, what's that, sales, sorry, mounts, Y label sales. This is Y label, right? Plt legends log best, and that's all. Plt show, here we go. This is how it looks like. You can add a grid here, grid through, sorry, I need to define the line style, line width is equal to 1, and line style is okay. There is something wrong here. I need to get this here. There we go. Plt show should be on the last line. Okay, here you have grid background, and you have scatter plot shows the correlation between sales and mounts, which increases, sales increases as time goes on, as you see here. There's a positive relation. All right, these are the line plots, scatter plot. How about other plots like bar plots, plt.bar. So it's really easy to call the function in Python, df.mount again, comma, df.faceWash, label, faceWash sales data. Okay, I will skip the labeling parts to save time, some time. Okay, there's something wrong. I did something wrong in here. It's mount number. It's not mount, it's mount number. Okay, so this shows me that, for instance, in mount 2, this is the number of number of sales for face wash, whatever it is. Is it cream or soup? I don't know, but it's over 1,000 sales. And it goes up towards the end of the year, as you see here. Sales of face wash is going up towards the end of the year. Okay. How about histogram? Some of you may know have heard the histogram, but for those who have no idea about the histogram shows you the distribution of the data. So here, let me draw it first and then talk about it. I was skipping the labeling part. Here you have, okay? So if you use semicolon, as you see here, this is the same thing with Plt show if you are using the same line of code, okay? So here, this is the distribution of the data set, the total profit, distribution of total profit. What we see is this, in between 20,000 and 25,000, 200,000 and 250,000, we have the data getter around this point, okay? This is the frequency that we have, and this is the numbers, actual numbers, okay? So these are the profit range, total profit. These are total profit. These are the frequency that they are observed within these intervals, Okay. All right. So we can say that the total profit distribution is skewed. Skewed because it's not symmetric. It's skewed to the right because we have outliers. This is my observation. We have outliers towards the right-hand side of the distribution. That's why it's right skewed distribution. We will talk about it in the distribution part. Okay, how about pie charts? Let me create some cells, labels, face cream, face wash, and then toothpaste, and then bathing soup, shampoo, and then moisturizer. These are the items that I have in my data. Okay, I close the brackets, open it and close it. These are my labels. How about sales data? I will try to show number of sales per labels, per items. Okay. In order to do that, I need to make some calculations. This is the trick that you need to do in pie chart. Face cream. This is the column selection, as you see here. Dot sum. I applied summation of the face cream, the sales number, summation of sales number, or total, or the profit. Sorry, this is the profit of the face cream. df face wash dot sum, the same thing, comma, df toothpaste dot sum, comma, df, let me click enter here, it's moving to the right, that's why it's not easy to track, soup, bathing soup, and some, comma, sorry, shampoo dot sum, comma, last thing is the moisturizer. Let me get it from here. It's not capital. Moisturizer dot sum. I hope I didn't do any typo here. Plt dot py. Please note that I always start with Plt dot in MATLAB environment, and depending on my visualization technique, this function changes. Sales data is my variable. Labels is equal to labels. Why is that? Because the name is labels. I can, not to create any confusion, I will change this. Labels is equal to items. Okay. Plt show. If I did any typo, I will see why I didn't do that. Okay. There is no typo. So these graphs tell me the shares that the items get from the total profit. So bathing soup takes the lion's share from the total profit, and then toothpaste, and then face cream, shampoo, moisturizer, and face wash. Okay, this is pie chart and looks fancy. All right, let me import another data set which has CSV format, salaries dot CSV, salary. Okay, and I will continue with that. Salary hat. Here we go. So salary data gives me the salary based on sex, years in service, rank, discipline, and PhD year that someone get. The PhD shows that how many years ago someone get the PhD. Okay. So Plt Box Plots. This is the final plot that I will show it to you in Matplotlib. Salary service. Okay. If I do that, this is what I have. So this plot has really important insights in statistics, because box plot gives us the indicates if there is any outliers in the data or not. So if you have circle here, you see there are 3 circles. These show that salary has some outliers in the data. So let me show the line plot. No, sorry, histogram to see if there is an outliers. Histogram is not a very strong tool to locate the outliers. It just shows you the distribution of the data. What we see here is that towards the right hand side of the distribution, we have numbers here. So what is the mean value of salary service? Let me calculate it for you. 15.05, somewhere here. Okay. We have, what's the standard deviation of it, by the way? STD 12. So, okay. If I have observation around 50, which means that this point locates 2 standard deviation away from the mean. Okay. If you type this by 2, 24. 24 plus 15 gives us almost 50, but not exactly. So it's somewhere here. If I, locate 2 standard deviation away from the mean, it's highly likely that it's an outlier. Okay. So here we see the outliers on the upper bound, not on the lower bound, because we don't. The lower bound is the minimum observation is from here. The minimum observation is 0. So our mean is, this service mean is 15 point, let's say 0, it's 15, let's say, for the sake of simplicity. So it's almost 1 standard deviation away, which is considered as not an outlier. So we have outlier on the upper bound. So this orange line gives us the median. Please note that it's median, not mean, it's median. And this box gives us the entire quartile, which means that this is the 25% of the data. This is the 75 percentile of the data. Okay. So this is all what box plot is all about. All right. How about Seaborn package? So Seaborn is more advanced visualization technique compared to the Matplotlib. Seaborn is a visualization library, as you know it, for making statistical graphs in Python. It's built on top of Matplotlib and closely integrated with Pandas data structure. Key functions that Seaborn offers are a dataset oriented structure for examining relationship between multiple variables, specialized support for using categorical variables to show observations or aggregate statistics, high-level abstraction, tools for choosing color palettes that faithfully reveals pattern in your data. All right. So if you haven't used it before, this is for you. ! Pip install Seaborn. Import, this is for me. Seaborn, import Seaborn as C and C. Okay. By the way, do you have any question? I'm sorry, I missed that. How was the x-axis chosen as mount and not other column from df? So let me show it to you. This is a good question, really good one. Okay, actually I didn't select the mount number at first. You know, where is that? Here, what you see is the index. If you didn't specify anything as x-axis, this is what you get. This is index. You see, this is from anonymous attendee. That's why I couldn't call your name. It starts from 0, ends at 11. So this is the index. So it's not a good way to do that. You need to specify df dot mount number. Let's do that. And then if you do that, this is exactly how you introduce the mount. So that's a good question. Thank you. Is Matplotlib identical to the plotting library in MATLAB, or it's similar? Not the same, but very similar. Above question for the very first plot. Yeah, got it. Okay. All right. Okay, let me continue with the Seaborn. Did I run this? Okay, I run the Seaborn package, and I call it SNS dot line plots. X is equal to service. Service is the column name, variable name here. Year of service. Y is equal to salary. Data is equal to salary. The name of the data is salary. I need to define it in Seaborn package, Seaborn library. I need to do that because it asks which data I am using. It's salary data. The name is salary. My x-axis, my y-axis. That's all I need to put. I don't need to put the semicolon, but it's provide better visualization. So here you see line plots between salary and service. So as your service increases, your salary goes up to certain point. From as of 50, it goes down dramatically. Okay, this is my observation. So some of you, I'm quite sure some of you know what the linear regression is. So linear regression is basically designed to detect the relationship between dependent and independent variables of your research, and it's designed to find the best fit. So let's do that. So I'm trying to explore the relationship between salary and PhD. So if you have an old PhD holder or a young PhD holder, how this affects this salary? Okay, then by using this code here, I find the best line. Okay, there's something wrong, I guess. Sorry. This is, I made a typo here. CNC. Okay, sorry about that. Here we go. Okay, the best fit line is this. This is going through in the middle of the data. So we have we have same distance on the left, upper side of the or the lower side of the line. Okay, this is the best fit line. The distance should be very similar. Okay, so the thing is, it's really easy to interpret this. All you need to is to focus on this line. This line shows that salary goes up based on PhD, year of PhD that you hold. Okay, so there is a positive correlation, almost one-to-one positive correlation. Okay, and if you type false here, you drop this line, and it turns out to be a scatter plot. Okay, great. What else we got? So I would like to show you something before completing the session. I would like to import a plot to do that. PNG. This is how we call the plot, call the already saved data from our local computer. You don't need to know this. It's not about Python library. I would like to show you something. That's why I'm calling this. It should be marked down, I guess. Oh, sorry, it should be called image series CRC Violin Plot PNG wild. Oh, I'm sorry. This code right here. Syntax error. Why is that? Alt and then image. Okay, image. Violin plot PNG with alt violin. What's the problem here? How about this one? Okay, anyway, I will show you later on. So I will talk about Violin plot. That's why I would like to show you how it works. Violin plot is a combination of box plot and kernel density estimation. Kernel density estimation is an empirical distribution. Okay, so depending on the data you use, you have a distribution. So this distribution, it's better to observe it in a plot because it gives you the important insights about the data, and Violin plot does it for you. Okay. Let me show you the Violin plot, and I will talk about it. Violin plot X discipline of it is field discipline. This is the field that people are working on. Sorry, PhD, and data is salary. Okay, this is what Violin plot looks like. So the white dot represents the median. White dot here represents the median. Okay. Thick gray is this. Thick gray, or this one. In the center represents the interquartile range. So we discussed this in the box plot. Let me show it to you. This is interquartile, corresponds to 25, 75 percentile. This is the same thing here, thick gray bar, and thin gray bar represents the rest of the distribution. Okay? Except for points that are determined to be outliers using a method that's a function of interquartile range. So the logic is the same with box plot, but the visualization technique is quite different because here you see is the kernel density estimation, which means that it's an empirical distribution of the data. Okay, here you see the empirical distribution of data. What it means is that the most of the point getters around the median here, you see? And we have similar observation here, but we have much more, we observe it much more frequently here because this is fatter than compared to this one. So we have much more observation around the mean compared to this one. How about the outliers? The points outside this thin gray line are outliers. So we have outliers here and here, lower and upper bound, and same with here, discipline. Okay? This is what Violin plot looks like. Okay. The next topic is the distribution, but I don't want to jump in distribution because if I start talking about it, I need to, you know, I'm not able to finalize it. So I need to restart it in the next session. So let me do it in the next session. In this last 20 minutes, we can discuss if you have any questions. So what's the horizontal axis of a violin plot? Horizontal axis is the discipline. You see, A or B. Let me show it to you. Where's that? A or B, you see? If it is B, it's, you see in the blue color. If it is A, you see on the, in the orange color, okay? And again, this line shows the kernel density. This thin line gives you the, this thin line gives you the distribution of the data, rest of the distribution, and thick gray line shows the interquartile range, okay? Outside this point are the outliers, okay? So this is interquartile range, this is the rest of the distribution, and outside of it are the outliers. Okay, any other questions? How about chat? Kernel density, yes. Kernel density is the distribution of the data. That's all. Kernel density. So this shows the distribution of the data. Can you talk how to fix the outliers as you said on that bar chart? Okay. It's a long topic. It's coming from Chef, I guess. I don't know if I, mispronounce your name. Sorry about that. How to fix outliers? We have different techniques. One of them is vinsorizing technique. If you do that, it's a strong technique, but if you apply vinsorizing, you manipulate the data, okay? Because you limit the values of data. The other technique is to ignore it or drop the outliers. These are other two options. You can basically ignore it or you can delete the outliers. The last one is to limit the effect of outliers by simply scaling them. How to scale the outliers? We can scale them by applying logarithm or taking square root of them so that we diminish the effect on the distribution, because outlier normally might have huge impact on the distribution. If this is the case, we need to deal with them. So taking logarithm, taking square root is a good way to do that, because we don't manipulate the data in that case. We just scale them. We scale all the data that we have. But in the vinsorizing technique, we scale the outliers only. Okay. How is variance bias on this Violin plot images? I didn't get it. Sorry, could you please rephrase your question? The question coming from Schumann is the visual symmetry of the Violin plot just for aesthetic? It is not symmetric, by the way. You see, it's skewed. it's skewed. We have more data towards the upper bound. You see? This is more symmetric. You are right, but I mean left versus right. Yeah. As you see, it's not, symmetric. It's the left and right is not symmetrically distributed. So here, this too. So as you know, if we have symmetric distribution, we call it normal distribution. We are going to discuss it in the next session, but it's not the case here. We don't have symmetric distribution. Okay. What else? Did I miss something here? I'm sorry, Randy, I cannot provide the notebook. As far as I know, you can use show if you, how to use Plt when you import. Dave, we use Plt show a lot. Oh, okay, you are answering another guy here. Sorry about that. Why codes are not sharing with us, please? You mean the Jupyter notebook? I'm sorry, we cannot, give you the Jupyter notebook, but you can take note from the video. All right, please discuss the variance. Okay, let's discuss the variance on Violin Plot. So sorry, there is one more question before that. I think he meant with symmetry about the mirror effect of the figure. Mirror effect of the figure. No, there is no such thing in here. No, there is no such thing in here. Okay. Please discuss the variance on the Violin plot. So variance, actually, we don't discuss the variance on Violin plot. It's not the kind of thing we do. You can do that. You can get an insight about the variance. You cannot calculate, or you cannot, do some more advanced, analysis about variance. But here, what we see is that the lower bound is around -10 and upper bound is around 70. And the median somewhere here, it's like 15 or so, okay? So the variance is a lot because we are going up from 15 to 70, okay? And we are going down from 15 to -10. So it's easy to say that variance is huge compared to this one because median is quite similar. Please, see this white dot here. But even if we have same lower bound, sorry about that, we have different upper bound, and upper bound is lower in the case of A. So it's easy to say that we have lower variance in A compared to B, okay? It's my observation. So visualization may misguide you. Let me do this by using a good and solid technique. Celery is the name of the data, celery.describe. If you do that, you can better understand it. So this shows you the basic statistics per column, okay? So if you want to calculate it, you can do that by group by what was that, service, right? Sorry, service variance. Okay, here we go. What was that? The service and PhD. I would like to focus on the PhD here. Oh, why did I have? Oh, sorry, it's discipline, not service. That's why. Let me take the discipline here, paste it here. Okay, here we go. So the variance of A, this is the case of PhD. That's why I focus on PhD. The variance of A is larger compared to B. So here, this mislead me. So the variance in the case of A is much higher than variance in B. So when I check this visualization, I think that I thought that the variance in B is much higher than the A, but it's not the case. So as you see, visualization might mislead you. So that please refer to this kind of application. Okay. How about bias? Bias in Violin Plot. So bias is actually something that we check the predicted values and the actual values. We don't have any prediction, but for the sake of discussion, I can say that if we focus on the median and the distance from median, and we can, it's not a good way to define the bias, by the way, but let's think for a second. This is the bias that we are dealing with. So the deviation or the distance from the median gives us the dispersion of the data. So you can think of it like this, but again, bias by definition is the difference between predicted values and actual values. So there is no bias here. All right, so how can you explain the purchases? Okay. Rafael asked a question about the selection in Pandas, purchases that I like 1, 2, and 1. So before the comma, we make a selection based on rows. After the comma, we make a selection based on columns. So if I type 1, sorry, if I'm talking about rows, 1, column, 2, which means that I start selection starting from second row, which corresponds to first, the 1, and end at third column. Let me show it to you, third row. Let me show it to you. Where is that? Pandas 1, 2. Okay. This gives me the second row. This gives me the third row, right? So this is my data, second row, third row, right? And the first column. And the first column. Sorry, second column. This is second column because first one is this, second one is this. So that's why, where is that? I choose John 15. You see? The intersection point. Okay, Rafael? Like Schumann asked, is the boundary on the left and right of the Violin plot for a mirror images of each other? No, it's not. No, it's not. It's the right-hand side of the distribution and the left-hand side of the distribution. So you can check the histogram here to get an idea about that. Here you see, this part corresponds to here, somewhere here, and this part corresponds to here. Okay, this is not a mirror image. I ran it and got different output with, sorry, Dave, I ran it and got different output with my earlier question, so it's not about me, I guess. Okay. Shit Hen asked a question, how to transform a data frame column to a list? Can I run for loop directly through the column values of the, yes, you can do that. You can do that. And how to transform data frame column to a list? You cannot transform data frame to a list, but you can transform list to a data frame. Or let me do that. You need to manipulate it. So if you have a list, let me type like this, and If you do that, and if you have same number of rows and columns, you can transfer a list into a data frame. But list has no specific rows and columns, so you cannot turn it into a data frame. You need to modify it first, and then only after that you can turn it into a data frame. And for your second question, the answer is yes, you can do that. You can use column values and run the for loop. Okay. Do you have another question? Would you able to share CSV files with us so that we can practice it? Okay, we can do that. I can share it with you. I will share with the administrative guy here in Magnimind that they will send it to you, I guess. They have the attendance participant list. Okay, I will let them know. You're welcome, David. Okay. Like Shuman also pointed out, the left and right curves for image. The left and right curves for A are either. Oh, you are talking about this one and this one. I just get it. Yes, that's right. That's right. These are the mirror image. That's right. I just got it. I'm talking about, I'm focusing on this part and this part. Yeah, there are mirror image, but it's it's not a big it's not a big deal. It's not a big thing to talk about. It's just an inner image. Okay. Thank you for this point. I missed this part. Sort of press the point, AK, but I agree with you. There is no horizontal symmetry, but there seems to be vertical symmetry. Yes, that's right. I just get it. I just get it. But there's no point here. You see? We have an inner mirror image, but there's no point. So I just focus on this thick and thin gray line, blue dot, and the point beyond this to check the anomalies. Okay. A question from Rafael. With respect to purchases 1, column 2, comma 1, I was expecting first column of the both rows 1 and 2, so I expecting 2 values. Okay, got it. So 2 is not included, Rafael. That's why. So even if you type 1, column 2, you just select 1. But I got your point. If you type something like this, let me show it to you. If you do that, this is your answer. You see? But if you do that, you just select first column. Sorry, second column. You just select second column. You need to play with this to get this. Okay? So the last value is not included. Okay. All right, guys. Thank you for attending. We are going to meet 1 week later and same time. I will share the CSV files. Take care then.